Hi friends, today we're going to talk about interpreting quadratics. So really the math that we're doing today is not new, it's just putting it in context of the real world. Let me remind you that our maximum or minimum value is always the y value of the vertex. So if the graph opens up, it has a minimum value. If the graph opens down, it has a maximum value. And again, it's the y value of the vertex. So these first questions here, the graph and the equation will already be given to us. And then the second part of this, we have to write the equation and then figure out the y value of the vertex. So a ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. This can be modeled by the equation y equals negative 5x squared plus 14x plus 3, where y is the height and x is the time. So they're telling me that x is the time, y is the height. What is the maximum height the ball reaches? So again, that's the y value of the vertex. So here, if I look at my vertex, the y value is 12.8. It's in height, so we have to figure out, is it feet? Is it miles? It tells me here that our units is meters, so 12.8 meters. How long does it take the ball to reach the maximum height? That's the x value of the vertex. So if I look at my vertex, again, my x value is 1.4, but we have to know, is it seconds, is it hours, is it days, is it months? Here they're telling me meters per second, so that means that my unit is seconds. How long before the ball reaches the ground? That's the x-intercepts. So if I look at my x-intercepts here, it looks like it starts with an x-intercept of negative 0.2. Well, something can't be in the air for negative 0.2 seconds. So let's look at my other x-intercept, which is 3. That means the ball was in the air for 3 seconds. So they throw the ball from here. It takes 1.4 seconds for it to reach its maximum height of 12.8 meters. And then it comes back down and hits the ground after 3 seconds. How high is the ball after 2 seconds? So they're telling me that the x value is 2, and they want me to find the y value. I know that because they're asking me for the height. So if I go to where the x value is 2, and then go all the way up my graph all the way up until I hit the graph, it looks like it hits the graph right there, which has a y value of 11. So it's 11 meters high after 2 seconds. And then the last one, approximately how many seconds is the ball 8 meters high? After how many seconds is the ball 8 meters high? So they're telling me, since height is y, they're telling me y is 8. What is x? So I have to go to where y is 8. If you see there, it touches 2 different times. It touches my graph 2 different times. The first time is about a half a second, I would say. Maybe almost, about 1 second. We'll say approximately 1 second and approximately 2.5 seconds. We're going to say approximately, though, because it's not exact. Or we can say about 1 second and 2.5 seconds. All right, you've designed a new style of sports bicycle. Now you want to make lots of them and sell them for profit. Your costs are going to be about $700,000 for manufacturing, for manufacturing setup costs, advertising, etc., $110 to make each bike. The profit can be modeled by that equation, where X is the price and Y is the profit. I'm going to write that here to remind myself. The first number in all these is the price. The second number is the profit. So what would you make, or what would you charge for each bike and make zero profit? So they're asking me Y equals 0. What is X? So when Y equals 0, that's my x-intercepts here. So it looks like my two costs, and this is money, so we have to round correctly, $125.60 or $334.40. How much would you need to maximize your profit? So again, that's the Y value of the vertex. Sorry, the maximum profit is the Y value of the vertex. They want to know how much we're charging per bike. So that's the X value of the vertex. So to maximize our profit, we would need to charge $230 per bike. And then our maximum profit is the Y value of the vertex. That is $10,900. So if we charge $230 per bike, we can get a maximum profit of $10,900. Small manufacturing company produces and sells products for a week. The profit can be modeled by that equation, where X is the number of products produced and Y is the total profit. So X is the number of products and Y is the profit. How many products should they sell to maximize their profit? So they're asking about the number of products. That's the X value of the vertex, which is 10. So they only need to sell 10 products to maximize their profits. What is their maximum profit? That's the Y value of the vertex, which is $92. What will the profit be if the company sells 6 products? So they're telling me X equals 6. What is Y? So again, I go to where X is 6, which is right here, up until I hit the graph. Excuse me. And it looks like this would be, if I go over, it looks like that would be $75. So if they sold 6 products, they would make $75. All right, one more like this. A toy rocket is fired into the air from the top of a barn. The height above the ground in yards after T seconds is given by that function. So this one is time and height. The maximum height of the rocket, again, is the Y value of the vertex. Anytime you see the word maximum or minimum, you're looking at the vertex, but then you need to determine, are they asking about the Y value or the X value? Here, since they're asking about height, I know it's the Y value. So the maximum height is 25 yards. They're telling me here that it's yards. How long is a rocket in the air before hitting the ground? Again, those are the x-intercepts. So either negative 1.23, which doesn't make sense, or this 3.23607. I'm going to round that and say about 3.24 seconds. At what times will the rocket be a height of 24 yards? So they're telling me Y is 24, and they want me to find X. I think we're going by fives each time here. So 24 will be like right about here. So they're saying y is 24. What is x? So if I go down, this looks like it's about 1/2. And this one looks like it's about 1.5. So about 0.5 seconds and 1.5 seconds. All right, the second part here, we're going to be writing our own equations. So our equation that we need to know is h of t equals negative 16t squared plus v sub 0 times t plus h sub 0 times t. You'll be plugging in for v sub 0. That's going to be our initial velocity. Initial just means starting. Velocity means speed, so the starting speed. H of t is our initial height or starting height. So a diver jumps off a platform at an initial velocity of 16 feet per second. So our initial velocity is 16 feet per second. Our initial height, if we look at our picture here, it looks like these divers are 30 feet up. So our initial height is 30. Writing our equation, h of t equals negative 16t squared plus our initial velocity, which is 16 times t, plus our initial height, which is 30. So all I did was plug in 16 for my initial velocity and 30 for my initial height. How many feet above the platform will the diver be at his highest point? So again, that is the y value of the vertex, which means we need to find the vertex. So looking back at our equation, a is negative 16, b is 16, c is 30. So if we find our time first, normally we would say x equals b divided by negative 2a. Here it's our time, b divided by negative 2 times a. So plugging this in, t equals 16 divided by negative 2 times negative 16, which means our time is 0.5. But now we need to find the height. So we're going to plug that into our equation. Height is negative 16 times 0.5 squared plus 16 times 0.5 plus 30. And if you put that into your calculator, you would get 34 feet. So the maximum height is 34 feet. It's not asking us, but it would take the diver a half of a second to reach their maximum height of 34 feet. This one says find the diver's maximum height if he dives from a 20-foot platform. So now our h of 0 has become 20, and our v of 0 has become 8. So now our new equation, h of t is negative 16t squared plus 8t plus 20. So our a is negative 16, our b is 8, our c is 20. We have to find time before we can find height. So b divided by negative 2 times a would give us 0.25 or 0.25. Plugging that into our equation, negative 16 times 0.5 squared plus 8 times 0.5 plus 20 will give us a maximum height of 21 feet. So if they were only 20 feet above the ground and they're starting at initial velocity of 8 feet per second, it would take them 0.25 seconds to reach a maximum height of 25 or 21 feet. One more here. Paul hits a baseball straight up in the air. The baseball's hit with an initial velocity, so that's my V sub 0, of 70 feet per second. When it's 3.5 feet, that's my initial height off the ground. We're just writing the equation here. So h of t is negative 16t squared. That negative 16t squared is always going to be part of your equation. It has something to do with the gravity on Earth. Plus our initial velocity times t plus our initial height. If you did want to find the maximum here, or if we did want to find the vertex, our t would be 2.1875, and our h, if we plugged it back in, would be 80.0625. So it would take 2.1875 seconds to reach a maximum height of 80.0625.